In today's lesson, we're continuing with lesson 3. We're on pages 410, and we'll be covering pages 410 to 413. I'm probably going to use 3 different colored pens, but that's optional. And then a calculator would be handy if you, just for adding and dividing, all right? And the homework is pages 416 and 417. So continuing with more with our two-way frequency tables. So we have this scenario here of smoking and asthma. So health officials in Milwaukee, Wisconsin, were concerned about teenagers with asthma. People with asthma often have difficulty breathing. In a research study, data was collected on the incidence of asthma among students enrolled in a Milwaukee high school. Students in the high school completed a survey used with this research. Based on this survey, the probability of a randomly selected student at this high school having asthma was 0.193. Students were also asked if they had at least one family member living in their house who smoked. The probability of a randomly selected student having at least one member in their household who smoked was, so at least one member in the household that smoked is 0.421. So I think I'm just going to kind of do an A for having asthma and an S for one member in the family, that at least one member in the family smoked. It would be easy to calculate probabilities if the data had been organized in the two-way table like the one used in question 6, which must have been yesterday's video. But there is no table here, only probability information. One way around this is to think about what the table might have been if there had been 1,000 students at the school when the survey was given. This table is called a hypothetical 1,000 two-way table. What if the population of students at the high school was 1,000? The population was probably not exactly 1,000 students, but using an estimate of 1,000 students provides an easier way to understand the given probabilities. Place the value of 1,000 in the cell representing the total population. That's already done for us here. Based on a hypothetical 1,000 population, consider the following table. So student indicates he or she has asthma. So I'm going to write A for asthma here, capital A for asthma. Student indicates he or she does not have asthma. Okay, so I'm going to say not asthma or not A. Number of no household members smoke. So I'm going to say not S. At least one household member smokes. S. Now, instead of the word not, we can also use this symbol, which is the tilde symbol. It would just be a little squiggle, which is the tilde. Where is it? It's to the left of the number 1 on the keyboard. So not S. And I'm going to say tilde A, which stands for not A. The probability that a randomly selected student at the high school has asthma is 0.193. This probability can be used to calculate the value of one of the cells in the table above. Which cell is connected to this probability? who has asthma would be cell 3. Use the probability to calculate the value of that cell. Well, if the probability is 0.193, and now we're talking about 1,000 students. So if I take 0.193 times 1,000, that's 193. So place 193 in cell 3. The probability that a randomly selected student has at least one household member who smokes is 0.421. Which cell is connected to this probability? At least one household member that smokes. Cell 8. Use this probability to calculate the value of that cell. 0.421 times 1,000 is 421. Complete the two-way frequency table above by calculating the values of the other cells in the table. Okay, so if I look at cell 7 here and cell 8, they would have to sum to 1,000. So what plus 421 equals 1,000? I'm missing something. Sorry. Yeah. Apologize. Okay. So I placed this in the wrong spot. So this goes with, this is cell 8, it's up here. And 421. Okay. Again, I apologize about that. So now, in addition to previously given probabilities, the probability that a randomly selected student has at least one household member who smokes and has asthma, so smokes and asthma, is 0.120. So smokes and asthma, so that would go in cell 2, 120. Okay, so now going back, right? Now going back and completing the table. So what plus 421 is 1,000, where 1,000 subtract 421 is going to give us cell 7, which is 579. 193 plus what gives us 1,000, or 1,000 subtract 193 gives us cell 6, 807. And cell number 1, what plus 120 would result in the total of 193, 73. And 73 plus what gives us 579, 506. And 506 plus what gives us 807, 801. No, 301. Okay, so now our two-way hypothetical 1,000 table is complete. There it is for us on the other side. Top of the next page here. Okay, now, based on your completed two-way table, estimate the following probabilities as a fraction and also as a decimal rounded to 3 decimal places. A randomly selected student has asthma. Okay, so we have a randomly selected student has asthma. So we're only looking at those students who have asthma. So I'm looking at this and this row right here. All right, when you're looking at these, what is the probability this student has at least one household member who smokes? We want probability. So, well, how many are there that have, of these students having asthma, that have at least one household member that smokes? It's 120. So it's 120 out of the total that have asthma, 193. So there's our fraction answer. Go to the calculator, and we're rounding to 3 decimal places. 120 divided by 193, 0.623, rather 0.622. B, a randomly selected student does not have asthma. Okay, so we're looking at those students that do not have asthma, which would be this row. What is the probability he or she has at least one household member who smokes? At least one household member who smokes is 301 out of the total that don't have asthma, 807. So 301 divided by 807, that's 0.373. Oh, sorry about that. Okay. C, a randomly selected student has at least one household member who smokes. So we're looking at a student who has at least one household member who smokes. So that will be, we're looking at this column, right? We're looking at this. What is the probability this student has asthma? So the student has asthma is 120 out of the total 421. Put that into the calculator, round to 3 decimal places. 0.28. Oops. Miskeyed. I was going to say 6, but I miskeyed. 0.285. 0.285. Do you think that whether or not a student has asthma is related to whether or not this student has at least one family member who smokes? Explain your answer. We're actually going to come back to this at a later time. Once we learn about conditional probability, which is in lesson 4. Right? This is the probability of A given that S, asthma given that in a household where at least one family member smokes, with the probability of asthma given that from a household where no members smoke. Okay, now unfortunately, the next exercise, there's a little misalignment on the pages here, so exercise 10 starts here, but I think most of the important information will be on the next page. So students at Kingston High School were discussing some of the challenges of finding space for athletic teams to practice after school. Part of the problem, according to Gabby, is that the females are more likely to be involved in after-school athletic programs than males. However, the athletic director assigns the available facilities as if males are more likely to be involved. Before suggesting changes to the assignments, the students decide to investigate. Suppose the following information is known about Kingston High School. 40% of the students are involved in one or more of the after-school athletic programs. It is also known that 58% of the students are female. I'm just going to put an F next to the 58% for female. And I'll put an A for athletic or after-school athletic programs next to the 40%. The athletic director indicated that 23.2% of the students at Kingston High School are females and participate in after-school athletic programs. Okay, so this is our and. This is female and athletic, after-school athletic programs. The students decided to construct a hypothetical 1,000 two-way table to organize the data. Complete the following table. So we have 40% of the students are involved in after-school athletic programs. So participate in after-school athletics, that's going to be A. That's 40% total. So that would be 40% times 1,000 is 400. And remember, our overall total is 1,000. That goes in the lower right-hand corner of our table here. Let's see, 58% are female. So for female, 58% or 0.58 times 1,000, 580. And 23.2% are female and participate in after school. So female and participate in after school, that's 232. So we've got the table started, so now we can fill in the rest of the information. All right, 232 plus what brings us to 400? 8, 6, 168. 400 plus 600 gets us to 1,000. 580 plus what brings us to 1,000? 420. Again, you can certainly pause and fill it in yourself. 232 plus what brings us to 580? 348. And 348 plus what brings us to 600? 252. The completed hypothetical 1,000 table organizes information in a way that makes it possible to answer various questions. For example, you can investigate whether females at the school are more likely to be involved in the after-school athletic programs. Consider the following events. Let F, capital F, represent the event a randomly selected student is female. Let capital A represent the event a randomly selected student participates in after-school athletic program. Based on the descriptions above, describe the following events in words. So not F or not A. So that would be, I guess it would be easier to say just males. Males or students not participating in. So this is males or students, males for not females, or not A, or students not participating in after-school athletics. F and not A. So that would be females and not participating. and after-school athletic programs. So on the top of the next page, you have the completed table. Based on the above table, determine the probability of each of the following events. So the probability of female, I'm going to do my same female, not female, athletic program, not athletic program. $580 over 1,000. And just leave the fraction answer. Probability the student participates in athletics, 400 over 1,000. Probability not female, 420 over 1,000. And you can stop the video and you can complete the rest of these on your own if you like. Probability of not participating in the athletic program, 600. Probability of female and participates in athletic program. Okay, so that's the 320, the 232 up here. And the probability of female or participates in athletic program. Okay, I'm going to use, oops, I wrote the wrong thing. Or I'm going to use the formula, right? The probability of F or A is going to equal the probability of F plus the probability of A minus the probability of F and A. You need to know that formula. Probability of A or B, the general form, is equal to the probability of A plus the probability of B minus the probability of A and B. You'll have to memorize that. So the probability of F or A is equal to the probability of F plus the probability of A minus the probability of F and A. So the probability of F is the 580 over 1,000. The probability of A is the 400 over 1,000 minus the probability of F and A is the 232 over 1,000, which is equal to 748 over 1,000. Determine the following values: the probability of F plus the probability of not F. So the probability of F is 580 over 1,000 plus the probability of not F. Not F is 420. Which is 1,000 over 1,000, which equals 1. The probability of A plus the probability of not A. A is 400 over 1,000 and not A is 600. It's another equal to 1. What do we notice about the results of part A and part B? Explain. The sums equal 1. What were these? F and not F, they are complements. And A and not A are complements. So because they are complements. The probability of an event plus the probability of the event's complement, right? Remember the superscript C is always going to equal 1. Okay, so you have the 2 pages, 416 and 417 for homework. And just to be sure that you kind of get started on it correctly. All right, I think you have no problem filling in the hypothetical 1,000 table. The first question is the first part is estimate the probability that a dog selected at random from those enrolled in the class. So that means you're only looking at dogs selected that are enrolled in the class past the course. All right, so you want pass the course. No problem there. A dog was randomly selected from the dogs that completed the class. Okay, so here you're only looking at the row or column where it has completed. So a dog was randomly selected from the dogs that completed the class. Completed the class. And the dog was a large dog. What is the probability the dog passed the course? So for C, you're simply looking at your pass the course. We're looking at large dogs. So the dog selected was large. You're looking at that row. Dog was randomly selected. All right, so this is nothing. If the selected dog is a small dog, right? Selected dog is a small dog. So now you're only looking at this row. Yeah, and that's it. And I think, yeah, and unfortunately, the misalignment in males and females. All right, and the same thing here. If a randomly selected eligible voter is female, so you're looking at this row, the females, versus if a randomly selected eligible voter is male, and you're just looking at, so your denominator for I here would be the total female is the denominator because you want probability. And for double I, the denominator is going to be the total for male. Just like if I go back here for C, the selected dog was large, so the probability, so the denominator is going to be the total for large dogs. And then for D, if the selected dog is small, the probability, the denominator is going to be the total for small dogs. Other than that, this homework is very short. Okay, thank you again for your attention.